Welcome to the video lecture on the course Op-Amp and Linear Integrated Circuit Laboratory. In this session, we will be seeing the experiment of low pass, high pass and band pass filter. So as we know, active filter is a one which uses the active components like the op-amps, and along with the op-amp the passive elements are used. A filter is a circuit which allows certain amount of signals or frequencies into the circuit and blocks or attenuates other signals. So in this case now we will be realizing three important circuit, that is a low pass filter, high pass filter and a band pass filter. So the objective of this particular experiment is to design and realize an op-amp based first order low pass, high pass and band pass filter for given cutoff frequencies to verify the frequency response characteristics. The final part of this is we have to plot the frequency response characteristic, that is the gain versus the frequency has to be plotted. The gain should be in decibels. So we will go first move on go to the design part of this particular circuit. So design a first order Butterworth low pass filter at a cutoff frequency of 1 kilohertz with the passband gain of 2. So here they have given the passband gain of 2. So in this case now the cutoff frequency or high cutoff frequency FH or FC is 1 kilohertz what is given. So for the design part we will select the capacitance value as 0.01 microfarad. As we know the cutoff frequency F is equal to 1 over 2 pi R into C. Knowing the values of FH and C, we can calculate the value of R. R is equal to 18 kilo ohms. So it is we are using a standard value. So actual value what we have obtained is 15.9 kilo ohms from the calculation part of this particular case. And now using this particular as a standard resistance value, so which is equal to 18 kilo ohm. Since the passband gain is 2 and ACL will be equal to, well, since it is a non-inverting configuration, 1 plus the gain of the op amp is 1 plus RF divided by R1 which is equal to 2. Therefore RF is equal to R1 what we are going to select, and it will be equal to 10 kilo ohms what we have been selecting in this particular case now. So we will draw this. This is the circuit diagram here. We will draw this circuit diagram, and after dragging up the circuit diagram in the, so we have to find the output voltage, the ratio and the gain in the decibel, gain in decibel. Frequency has to be varied for this particular part. So moving on to the circuit in the rigging up the circuit in the multisim software. So moving on to the multisim software. So this, as mentioned, so this is a circuit diagram which is already I have already rigged up here. So this is a circuit diagram which is of the low pass filter, the resistance and capacitance. So we are using 18 kilo ohm resistance. Actually it was 15.9 kilo ohm what we had obtained. So now we are obtaining it as 18 kilo ohm. This is the value of R. Since here when we insert the values of different values of resistance, it the system takes it as R1, R2, R3 different resistance values. So we cannot edit the parameters here. For that reason we have considered it as R3. So R2 and R1, that is R2 is nothing but RF here. So this is equal to 10 kilo ohm. So now directly we will be executing this. And one another important thing is we are using a function generator. So if I double click on this function generator is going to provide the three different type of signals. One is the sine wave, triangular wave and a square wave. So here frequency is a variable part what we can see. So I will set it nearly to 50 hertz for this particular case. The amplitude of 1 volt peak, so peak to peak voltage will be equal to 2 volts, and I will keep this window in an open condition, and I will open the oscilloscope at this particular part, and I will be executing this on execute part. So when I execute this for 50 hertz frequency, the yellow color waveform, that is the channel 1 is the input waveform, and blue color is the output waveform. So as the name of the filter suggests low pass filter. All low frequency signals will be allowed, so it is amplified version. So here channel 2 is 1 volt to go. So if we go for measure part and channel 2 type, so frequency, here we can see the mean type. Peak to peak voltage is 4 volts. So peak to peak, it is a amplified version what we get for a channel 2. So now what we will be doing here is we will vary this frequency. I will vary it to 100 hertz and I will click it out here. So here as the frequency varies, the gain is almost the same what we can see here. It is 3.96 peak to peak. So we will be varying this. So I will be varying the frequency through this part here. You can see, observe this particular function generator frequency. So frequency has been varied, whereas the amplitude of the output voltage is almost the constant, but decreasing by 0.1 value. As you can see, the peak to peak voltage of the peak to peak voltage at channel 2. So I will show you the channel 1 peak to peak voltage also. So it is 2 volt peak to peak. Channel 1 is 2 volt. So we will see, observe for peak to peak, and I am going to increase this, increasing this. So in steps we will be increasing. So I have increased to 500 hertz. So it is almost the same. It is a 3.47. It has starts reducing since it is a practical case and values are of not so exact part. It has been varied. So now 800 hertz we have included. So I will include it, increase the frequency. So as the frequency is increasing, the voltage, peak to peak voltage starts reducing. For higher frequency, the voltage starts reducing. You can observe the waveform on this particular oscilloscope here. The peak to peak voltage has started reducing. The cutoff frequency what was designed was for 1 kilohertz. At 1 kilohertz it reduces at minus 3 decibels. So in this way the value of the output reduces as the frequency goes on increasing. So we will be varying above 1 kilohertz. Now the output voltage starts decreasing at this particular instant. So as the frequency is varied at this particular point, the output voltage is going on decreasing, what we can say. Now I have reached 9 kilohertz and see the output voltage. The channel 2 output voltage is almost 387 millivolts peak to peak value, which approximately we can consider it as it is blocking the higher frequency signals at this particular part. And with this particular intention, we can say that the low pass filter allows only the low frequency signals and attenuates all the high frequency signals at this particular instant of time. Now further moving on to this particular part, I will just execute stop the execution part and moving on to the observations part. Frequency has to be varied. Input voltage, what we have set was 2 volt peak to peak, which is nothing but 1 volt peak. Output voltage has to be noted. Then we are noting down the transfer ratio, that is the output voltage to input voltage, and finding the gain. And final part will be, we will be plotting the gain versus frequency, which is nothing but the frequency response curve. Initially the gain will remain constant. At the cutoff frequency, the gain decreases to 0.707 times of the passband gain, and then frequency reduces as we have seen in this particular part. So this is about the low pass filter. So the next, moving on to the high pass filter, we will discuss this high pass filter in the next video session. So thank you for watching this session.